Welcome at this first Syllable conference of 2012. If the world doesn't collapse, we'll have another one this year. We had a few major items in the program, and the main one is a new Syllable release. It's not completely finished yet, but what you're seeing now is the login screen of a new Syllable desktop development build. There we are. It's been a very long time since the last Syllable desktop release. Obviously the project isn't going as fast as it used to be several years ago, but we're trying to do what we can, and there's a particular problem in releasing a new Syllable desktop version, because Christian, the project founder, always did the builds. He was the build master, and he's still in the project, but he's not really active anymore. So I'll have to try to replace him doing the full system builds. As you probably know, I designed the Syllable build system, so I've been doing a lot of build work, but I never did the complete system build. So I'll have to get those in my fingers as well, as we say in the Netherlands. If I'm a bit vaguer than usual, it's because I didn't have time left to sleep this night, because I was working on finishing this build. It's not a complete build from the source code, because I'm replacing our former build master. I've decided that it's too much work to do it completely from source for the first time. So this is built on the previous development build, the development build going towards Syllable 067, and I've taken that binary build and made a lot of fixes and additions to it, because when we made the last development build, which was also quite a long time ago, we were working towards Syllable 067, and we were getting fairly close, but there were still a series of build failures at the time in the last development build, so I had to fix those. And I made a number of additions of stuff that we did since then as single stuff, and I had a look at what I could add to the system that would be useful and that would work fairly quickly. And particularly I have a few objectives of parts that I want to include in the system that I'm working with, and that I want to consolidate in Syllable releases to make it easier to build upon them. So let's see what we have in here. Fairly obvious new stuff is here in the applications. Last year, about half a year ago, I worked with Bogomips, as he calls himself on our forum, and the question came up about OpenGL 3D and why we don't have it yet. And actually we have been working on OpenGL many years ago. I forgot if it was 2007 or it was actually 7 years ago, so it was 5 to 7 years ago that we attempted the first ports of Mesa 3D. And Mesa 3D is the open source OpenGL implementation. And the problem with it was that, as unfortunately with many contributions that we get, it wasn't finished, and it wasn't even working at the time. And Mesa 3D is a large subsystem, and we really couldn't get it to work at the time. And we had a screenshot, actually a single screenshot I think, of only one texture that was shown in 3D. And actually I think Christian got it to that point at one time, but when I started integrating it in the build system, we could never get it to that point. So it was never at the point that we could integrate it in the base system. And nobody continued with it, and it wasn't really finished. Well, actually someone did continue with a version later, and a somewhat newer Mesa version seemed to be at the same stage, but it was also unfinished, and the demo of the previous version never worked on that version. And about half a year ago, Bogo Maps inquired about it, and I thought that it was a good time to have a look at it again, because he had been porting about 80 SDL programs last year, and I thought it would be nice if we could extend that to 3D SDL programs. We're not at that point yet, but I had a look at the state of OpenGL in the build system, and I got the two old versions after a lot of extra work over the years. We've worked on it several times, put a lot of effort in it, but half a year ago I actually got those two old versions to work with the old demo texture. But by now they're really antiquated almost, because there is an elementary Syllable video driver in there that you need to show that demo. But by now Mesa 3D has gotten a whole new driver architecture. So if you want to have a new Mesa version, you need to write a whole new driver. And actually the driver was very primitive and incomplete to begin with. So it's not really something you want to continue with. So I did get it to work to see what the state actually had been 5 or 7 years ago. And then with that knowledge, knowing that it could work, I had a look at the newest Mesa, and I actually ported it, but without the video driver, because it needs to be completely rewritten. So we're between a rock and a hard place with 3D. We have the old Mesas that you don't really want to continue with, but they do have a primitive Syllable driver. And I've ported the new Mesa, but you can't get it on the screen yet. But what you could do with that is you could program it in memory and render a 3D picture in memory, and then put it on the screen in some primitive way, not directly through a video driver. But that's the state of Mesa at this point. And there's really very little you can do with it, because if you want to program the old versions with the video driver, you need to program the Syllable video driver, which is very primitive and incomplete. And so it's not really something that you would want to write programs on. And as I said, the new version doesn't have a video driver at all, so that's also not really a state that you want to program. In any case, it's not what SDL 3D programs would need. They would need the standard integration of OpenGL with SDL, and that works differently than a native Syllable driver. So after a lot of work over the years, we still don't have much, but we do have this, and actually I've shown that on the last Silcon when we were working on it.
On steroids.
Yes, on steroids, because at the time I showed it on the 13 years old laptop, and this is running much faster because this laptop is only 6 years old.
And now it's somewhat slower.
Yeah, that's the exact same thing you said half a year ago, and that's only logical because they run at the full speed of the CPU. That's why they're too fast to begin with. And then when
you start more, it gets slower.
Yeah, when you run two of them, you get half the speed. So they're each running at 1/5 of the speed now that they started out running at. You can see here in the meter, the CPU meter, that the CPU is at 100%. So they're really sharing the CPU time. Here's a small separate CPU meter. And to be complete, I could add the memory monitor to it. It's really the large version of what you already have here in the dock bar. And the old laptop had only 192 megabytes of memory. It really doesn't need it for this demo, but this new laptop has 2 gigabytes. And actually, Syllable Desktop can't handle that. It limits the memory to 1.5 gigabytes. So we have 1.5 gigabyte available, and the system plus these demos uses a very tiny fragment of the memory. But it does use the full CPU speed because this is really rendering intensive. And actually I haven't said yet what this is, but we'll get to that. As last time, you can move these things with the cursor keys. It's fairly standard for Open 3D demos. But this is nice because you can get it on, you can put it on wireframe, and you can actually see that it walks faster now because it's only drawing the wireframe now and not all the texturing, so the computations are less intense now, so that speeds it up. And now when I tested this tonight, it turned out to be unreliable, because it hung at 100% CPU when I started closing them. So we'll see what it does now. See, all the remaining ones are going faster now. This one is so fast that you really can't see it anymore. And now the gears are so fast that you can't really see them anymore. And now this one is so that you can't really see the movement very well anymore. This is a nice one at full speed. Oh, this time it nicely goes back down to idle. See here in the CPU meter, it only at the last demo it falls back to almost 0. Because it keeps using all the processor time. And the point is, this is software rendering, So at the old laptop it was fairly slow. And these are really old demos, so they're not really fast here either, because they're fast, but if you run modern 3D programs, they have much higher requirements, and then you really need hardware rendering. But hardware rendering is really hard to do, because you need the entire subsystems present, the whole stack in Syllable, and we simply don't have that yet. We don't have direct memory, direct rendering drivers. We don't have any 3D hardware support, so we have to start with software rendering. And Mesa 3D is actually a software rendering, but you can write hardware drivers for it, and then the software rendering in 3D in Mesa 3D becomes a fallback. So if your driver supports all the hardware operations, everything will be accelerated by the graphics processing unit, the GPU, the video chip. But if your driver is not complete, or the driver or the hardware simply doesn't support all operations, then the Mesa software rendering is used as a fallback, so that you still get all operations in the OpenGL interface. And the point is, if you don't have hardware drivers, then everything will fall back to the software rendering. So also, if you would start with Mesa 3D, as I've ported the latest version, if you would write a display routine around that for SDL, or maybe a new Syllable video driver, it would also be software rendering to start out with. But this is not Mesa 3D. This is Pico Gl, as I showed at the previous Silcon in the demo version. Pico Gl is built on TinyGL. TinyGL is quite old. It's from '99 or something. It's a software OpenGL implementation by Fabrice, I believe Fabrice Bellard, the same guy who later wrote QEMU, the machine emulator. So, and I think he did TinyGL when he was a student. So he's really one of the great programmers. And this software implementation is still around, and it's still being used on alternative systems that don't have hardware rendering yet. And the software rendering is supposed to be faster than Mesa 3D, and that's probably because it's simpler. It's a subset of OpenGL. I believe it's a subset of OpenGL 1.1 or maybe 1.2. And the latest Mesa that I ported, 7.10.3 or something, from Mesa from half a year ago. That's a much newer OpenGL version. So it's a mixed bag again. This is something that really works now, and this works because TinyGL had an X11 backend, and it once had a BOS backend and a Nano X Windows backend or something, but a later project added an SDL backend to it, and then Pico Gl extended that a little. The lineage is a bit vague, but Pico Gl is the newest attempt to continue the TinyGL implementation with the SDL backend. So that was a good one to port to Syllable. So it's running on top of SDL. It makes it quite portable. So it's a subset of OpenGL that is software rendered to SDL in this case. And it's a bit primitive, and it's quite old, but it works, and you can really do things with it. And we can't do that with the Mesa ports yet. The old MISA ports simply have a very primitive Syllable video driver, and the new MISA 3D port that I made needs an entirely new Syllable video driver. So this Pico Gl thingy is really the most usable at the moment. And well, I think I can say that I've been looking into it for some time to do this for Red, the new language. I've been planning how to write a Red binding for OpenGL, and you always, if you need to do something big, you should try to cut it in small steps to make it easier and to get it to work sooner, to validate your work. So my plan is to make a Red binding with TinyGL, because it's a nice OpenGL subset. And if you do that on this Pico Gl implementation, then you'll have a way to write Red 3D programs that will run on Syllable Desktop. And then after you have the subset of OpenGL 1.2, you can extend it to MISA, and then you can support newer and more complete OpenGL APIs. But if you start small with the TinyGL subset, then you'll have it working on Syllable Desktop. Well, Red is another story. It's the same as Syllable. It's built from the ground up, and there's a lot of stuff to support to match other programming languages and the bindings that they have available. And OpenGL is one of the big ones. And you have to see when you'll be able to do it. Red is about a year old now, so it's really very young language, and the high-level Red language isn't there yet, so it's only the low-level Red system language, but that's the level at which you want to make bindings. And you can evaluate if Red system is complete enough yet to do something like an OpenGL binding. And the thing is, OpenGL uses floating point values everywhere, and it uses mostly double precision floating points, but in some places it also uses single precision, so you need to support them both. And for example, if you would only have the support of Rebel, Rebel floating point numbers are double precision floating point numbers. If you would want to try to write a Rebel binding for OpenGL, you have a conversion problem with the single precision floating points values that you need to have in the OpenGL interface. And actually this Pico Gl thingy is interesting because it's a pure software implementation. You could force it to use double precision floating point values where actually you should use single precision, and you just recompile the thing because it's just software. And then you have an OpenGL API that's not compatible with the standard, but you could use it with only double precision floating point. So you would have to jump through such weird holes if you would want to make a Rebel binding for Rebel 3, for example. And with Rebel 2 it would be pretty much impossible to make an OpenGL binding, because the old binding interface for Rebel 2 is very primitive. It can't support callbacks, for example. And almost all interfaces need callbacks in some places. I'm not even sure if OpenGL needs them. I haven't looked into that yet, but it probably will. There are very few bindings that don't need callbacks. And you have the single precision problem in Rebel. And actually Red System didn't have floating point at all yet until 1 or 2 weeks ago. And Nenad Rakocevic, the author, we've been bugging him about floating point all year. We wanted to postpone it, but people writing bindings said that we needed it, and it's really a difficult choice. Do you prioritize implementing the red language first because everybody's waiting for that, or do you support binding writers first because that gives you the functionality that everyone wants? So whatever he works on, it's very important, and it's great if we have another milestone. And the nice thing is that he has started on floating point support maybe 2 weeks ago, very shortly ago. In the first weekend he already had a halfway floating point support that you could use to shuffle values to bindings. But he has decided to make it a full-time priority, and now 2 weeks later we have a quite complete floating point implementation in Red System. Only a few things are still missing, but you don't really need them for most bindings. You can do bindings and you can do most computations now. And actually at first it was just double precision floating point, but half a week later he suddenly had single precision as well. So Red System has double and single precision floating point now, and that's exactly what you need to make an OpenGL binding. So I had already planned it, and well, I couldn't sleep tonight because I had to get this Syllable development build to work. But next week I'll have to really finish the development build so that we can put it on the website and have a few people test it, hopefully. And then I'll start on the OpenGL binding for Red, because that's really within reach now since last week. So that's a bit of a surprise, a bit of planning for next week. I don't think really many people will watch this video on the internet anyway, so people probably won't even notice it. Then, so you know that's planned for next week. And the full OpenGL binding is a lot of work. And at first it will be a little bit specific to Pico Gl, because the first target is to get it to work on this SDL backend. And there are a few changes here in Pico Gl that are almost standard, but the SDL backend is somewhat visible in it. So it's not entirely standard OpenGL code. And well, yeah, we have these 5 demos here. And a few of them are very simple. The cube and the spin and the texture are quite simple. And the mag is the most complex one. So I want to do at least one simple binding of these. They're written in C. TinyGL is written in C, and these examples are written in C. And Red System is a language almost at the level of C. So I want to rewrite at least one of these bindings at least one of these demos in Red System to test and to show how to write OpenGL programs in Red System. And later on Syllable Workstation I'll show my GTK Plus binding for Red, and that's actually a very interesting one, because well, the standard question is always, why do you want to make a new language? And my GTK binding is really a good answer to that, because it implements a dialect for GUIs, for GTK GUIs. And that's something that you can't really do with other languages. That's really the forte of Rebel. And the interesting thing is that Red System is much lower level than Rebel, but there has been one enhancement about half a year ago, around the previous Silcon, just the week before I think, and one little enhancement, runtime type information, for specific functions that allowed me to write a Rebel style GUI dialect, and that makes Red System quite different and quite more advanced than many other languages. And it's likely that a similar dialect can be made for OpenGL. And eventually you want to make all those dialects in Red, but Red isn't there yet. So if I make an OpenGL binding anyway, I'll probably make a simple OpenGL dialect on top of that makes OpenGL programming much nicer at a much higher level, much better abstracted from the boilerplate details that must be written in other languages. And actually, a year ago, at our first Rebel DEF CON, the next one is 1 month from now, but the first one a year ago, where we launched Red, we had a Boron OpenGL demo. You were there, right, Freddie? And Hilla doesn't know, I think. We had Boron is another Rebel-like language, but it's at the same level as Rebel. It's a high-level interpreter. So the point of that is that you want to make all those dialects, and it has a GUI dialect for Qt, and it has a dialect for OpenGL. And but it's less modular. Bindings are much nicer and much easier for external people to write in Red System. So nobody outside the Boron author has done anything like that, but it has Qt and OpenGL built in. And there was a 3D demo that we worked on with him to get it to run on not the newest hardware, and it was the Starship Uss Enterprise. You know that, right? You can get those 3D models on the web. So if you find a few of those models, and there was a texture of a planet, there were some stars with and lens flares. If you looked right up into the sun or something, and we had a very nice demo, but that needs a much newer OpenGL version, and it really needs hardware rendering. And at first it was only smooth on very new hardware, but we tweaked that a little, and then it ran okay on 5 years old hardware, which you do really need hardware acceleration. So we showed that on Linux Mint, but it was programmed in Boron, and when I do a Red binding, I'll have a look at the OpenGL dialects that are in Boron, because that's probably about the way you would want to do them in Red. And there's a good chance that you can already start doing a simple dialect in Red System. So that's really added value compared to almost all other languages. So that's really, that was the main reason for Carl Sassenrath to design Rebel, and that's really the main reason why we still want to do Red now that Rebel development is stalling. So that's the state of OpenGL right now in Syllable and in Red. Nothing is there yet in Red, but I hope there will be in 1 or 2 weeks. and then we'll of course try to get it to work on Syllable first, and then from there you can get newer niche OpenGL versions to work, and then you can get it to work on Linux, and then you'll have hardware rendering available, and you can implement newer OpenGL versions and more heavier demos like the Boron demo. Any questions, remarks?
On a average Linux machine, what would be the CPU usage?
Same, 100%.
No, I mean when doing nothing.
Oh, when doing nothing. Yeah, we've talked about that a few years ago. The nice thing is that if you do nothing in Syllable, you'll have a CPU usage of what you see here, 0.3 to a 0.5%. And you see it going up even if you just move the mouse. That costs a little. And if you move a window, that'll cost a bit extra. But because these windows have hardware backbuffering, this is not a 3D video system, but it does use hardware backbuffering even in 2D. So at the moment these windows all have their own hardware backbuffer, and that means that things like moving them really don't cost much CPU time. It very shortly spikes to almost 10%, and that's it. What should be heavier is resizing it, because then you really have to do computations, see?
Yeah.
Then you go to 20%, maybe 25 shortly. And this is in the background a more complex window. So if you would resize a more complex window, then it should cost a little more. But it's really not that much. Oh, this is the thing you like so much, the Alt-Tab preview of Windows that keeps animating while you're there. See, here's the CPU graph. That animates in the Alt-Tab window switcher preview. And even now it takes, with this preview, it takes only a few percent still.
We should have tested this when running all those demos.
Oh, then it'll run the same.
Yeah.
But the 1% usage will be taken away from the 3D demos. So the demos will run 1% slower.
Yeah, I mean it would be cool to see in that window that all the demos still keep running.
Yeah. Well, this is really the Amiga style multitasking. See, it's 100%, but the drawing of this graph doesn't slow down. It's not bothered by it, and we know from back then that drawing this graph takes a 0.5% CPU, and then taking the preview.
You don't get to see the demos in the Alt-Tab window.
No, because that's too fast.
Okay.
Yeah, there is a limit to it.
Okay.
See, you can still preview the graph because it's drawn slowly, so that's no problem. but the OpenGL stuff, it animates too fast, and apparently it decides, or it happens to not take snapshots then.
Yeah.
And it could have something to do with SDL, but I don't think so, because it's just software rendering. So eventually it gets into that Syllable window anyway. And what this preview does is take a snapshot of the window. But you get the same effect if you see this is all very smooth. There's no way to see that 100% of the CPU is used, because everything you do in the GUI, it just happens because you want it to happen. So the system does that, and all the remaining time goes to the drawing of the 3D animations. And actually it's split equally, but because this preview plus the drawing of the graph takes only 1.5%. There's no problem at all for the graph in this preview to run at the intended speed.
But you're not sure if it doesn't show up in the alt-tab window because it's SDL, or because it is at 100%?
It could be, but usually the only reason why something doesn't show up is that it would be a hardware window. Mm-hmm. If you have a video player like the Syllable player that plays its video in a hardware overlay, and that usually even has a different color space than the normal hardware back buffers, then it can be a reason why screenshots don't work. And but I think this is just too fast. It's too fast to take a snapshot, because we can try to do that, and I've tried to make a screenshot of this, and it gets very ugly, because let's see here, the dock preference. If I add the camera applet, then I have a camera here, and I think I can never remember, I think you need to double click this. See, and then you see the cube slowing down shortly.
Does it show up on the desktop, the snapshot? Or?
No, not on the desktop, it's in the pictures. Take home, of course. Home, pictures. Okay. I see. I have two, so maybe single click works, I'm not sure.
That's pretty well.
Oh, it's quite okay now. Oh, that's because this machine is faster. Because I made a screenshot on a slower machine, and you can see it here. It doesn't take one screenshot. It takes the screenshot of the window of the whole screen, but when the screenshot is here, the 3D demo already draws a new version, and then when it has drawn that, the screenshot is only here, and then it draws another version. So the screenshot has time for taking this part of the screen, while one frame of the animation is drawn, even when two of them are running at the same time. So you get a tearing here. So you get a very, very ugly screenshot.
If you got any idea how long the shot is, how many microseconds?
Well, that's the point. It needs to read the video memory of the entire screen. Mm-hmm. And the point is, it takes so long to do that the 3D animations are much faster. You can have several tens of animations while the snapshot of the desktop is taken. And that could be because it has low priority, I don't know. And what it should be doing is that a snapshot should be locking the video, the part of the screen that it wants to snapshot. But at the same time, if it did that, it would distort the animation. So it's a choice. You can have either the animation cleanly running, or you can have a clean snapshot. And apparently the way it works right now in Syllable is that the animation keeps running, and taking the snapshot has probably the same priority as the rest of the application. But for some reason taking a snapshot seems to be relatively slow, and that means that if you have fast animations you get a very ugly screenshot. But other than that, it's very clear, very clean. Oh, this screenshot is actually pretty good, because this one happened to be in a slow part of the animation, probably the cube. It looks better on this faster machine, so maybe that does something to the relative speed of the animation and the snapshot. I don't know. Could be. But yeah, you can simply you can keep working. Everything is fast while still 100% of the CPU is taken by those animations, because the whole GUI gets everything gets equal priority basically, and that was the same thing on Amiga, and it's the same thing on BOS.
But is that also on Linux or not?
No, it's in general X is very slow and laggy and clunky.
No, but I mean the dispersion of the resources, the sharing of the resources.
Oh, that's the point. That was what the whole fight was about between Con Califas and the kernel people. Con wanted a fair scheduler, and a fair scheduler means that everything gets a fair share of the time. And that's pretty much exactly what this does.
Fair in the meaning of what is reasonable for that kind of application? Or everybody the same?
The scheduler cuts the CPU time in slices.
Yeah.
And every running process gets a slice. But the point is, if one process, both these animations want 100% of the CPU.
Yeah.
If you give them 100%, they'll take it. Mm-hmm. If 100% is available, it's fair. Mm-hmm. Why not give it if it's available? So that's why the machine is running at 100% now. And if you close one of them, the other will get 100% instead of 50%. Because it's available. But it wouldn't be fair if this graph, which takes only 0.5 to 1% of the time to draw the graph itself, it wouldn't be fair if it couldn't do its work, because it wants so little for itself. So the whole multitasking is such that it's so fair that if a process is fair enough to ask only 1% of the time, it will have no problem getting it. But on most other systems, if you have only one process that wants 100% of the CPU, all the other processes will slow down very visibly. And what you do see slowing down is when you start a new program. If I open this filer, it takes a bit longer than if you wouldn't have CPU monopolization by the animations. So some things are a bit slower, but that's also logical, because this graph takes only 1% or 0.5% of the time. But if you start a new program and its window has to pop up, then the program needs to be loaded in the background, and it takes about a second. And during that second, the machine is using 100% in principle, to start that program. And it could be less than 100% CPU because it's probably large parts of it are I/O bound. So it would use the hard disk 100% and the CPU 50%, for example. But during loading of an executable, parts of it are a heavy CPU task. And then it's fair if two animations are running at 100% CPU and you want to load a 1 second program that would take most of the CPU time, then it's fair that it gets shared with the two animations. So then you get a visible slowdown in starting a program, because if it would usually take 1 second and you have two animations running, then it's fair that it would take 2 or 3 seconds, because it needs to share the CPU time with the two animations. So that's basically fair scheduling. And the Linux kernel never did it until it got the completely fair scheduler, CFS, a few years ago. And it got that because Con-Califas made his own scheduler, which had a fair scheduling algorithm. And Linux didn't want it in the kernel for all sorts of political and semi-technical reasons. And someone else, I think Ingo Molnar, did the completely fair scheduler, and that was philosophically was like Con-Califas scheduler. It's just that Con says that his scheduler is more fair, because Linux is always optimized for server use, and that always means throughput in the first place. And you want the desktop system to be optimized on responsiveness in the first place, and also in the first place on the user interface. Only the interesting thing is that basically there is no prioritization of the user interface here. It's so fair, the scheduling is so fair, that everything runs so smoothly, because if you need very little time for a graph, you will have no problem getting it. So it will always look the same speed because it takes so little, it needs so little time. And big things are shared fairly. And if you then want to load a program that takes a good amount of CPU time, it will visibly slow down, because a fair share goes to the animations. And there's no basically no prioritization of anything. It's just the time slices are divided fairly.
But when you now would open, for example, Webster, and you take the full screen, the demos, they keep rendering?
Yeah, and then it basically still takes the same time, because most of the time is spent computing.
Yeah.
And the fact that that you don't have to draw the things anymore, it doesn't make a big difference. But you could see if I minimize this one, you could look if the gears are going faster. And it actually looks like they're going slower, but that's probably a figment of the imagination. The speed does change. So
because it then knows it doesn't have to be computed.
Yeah. No, it still needs to be computed, but the computation doesn't, and it also goes to the video memory, the memory that's, and this is a hardware back buffering, so it should go really to video memory, but it doesn't need to be rendered anymore. So there's one part of it, it doesn't need to be shown on the screen anymore.
Yeah, but I mean,
it doesn't need to be composited on the screen at this time, and that's why it does make a difference.
Yeah, but with this demo, I mean, it doesn't matter now for me as a viewer if it is being computed, but the system itself doesn't make a difference in that. It's still
you do need it to be computed, because if you click it into view again, then you want it to have progressed. You want it to keep running in the background. So if you get it into the foreground again, then you expect that it is further on in its animation. And to keep the animation running, you need to keep computing. And if you have that computation, you also need to send it to video memory, probably because this is hardware back buffered. But it is possible that there's an optimization that it's not even sent to the video memory at that time, and that's why it makes a difference in the speed. We'll try to do it the other way around. See what the cube does. See, in the cube you can see that it goes slightly faster. So that there is an optimization in the Syllable video system that if you click it away, then it makes a small difference, because the computations keep running. That's simply the demo, but the screen doesn't need to be shown anymore, and that makes a small difference in the CPU utilization. But about the comparison with Linux, which is mostly a comparison with X11, but also with the scheduler in the Linux kernel, if you take a process to 100%, then all the other processes will very much slow down visibly on the screen. So that's one rather obvious difference. If I try to do this, what you just asked in Linux, then my experience is that you do not get time back. It does not speed up if you minimize a window in Linux. And maybe it does if you run a 3D hardware accelerated composited desktop nowadays. But in any case, if you have X11 with 2D rendering, then in my experience it makes no difference if a window is minimized or not. There's no optimization to get that time back as far as I can see. So that's the difference. But the very biggest difference is with Windows, because if you do something like this on Windows, to get it to run smoothly, seemingly smooth, in Windows the processor time goes to the window that is in the foreground, the window that is active. So if I did this, then the cube would slow down, and if I then focused the cube window on Windows, the gears would slow down. And in the Amiga BOS Syllable multitasking system, there's no such thing. The time is also shared fairly, scheduled fairly, between focused and non-focused windows. And the trick they do in Windows to make it seem smooth is to send all the time to the foreground window, because you're probably running your animations in the foreground window.